Hello everyone, welcome to another video of class 10 general science, and today we are going to continue with the chapter carbon. So we completed up to a certain part where we saw about homologous series and all, and today we are going to start with another important topic called the functional groups. So there are, in the book, the NCERT book, they have given us 5 functional groups, and there are 5 functional groups. So what are they? What do you mean by a functional group? First of all, a functional group is nothing but a simple molecular formula, a small molecule which will be attached to any part of a carbon compound. So for any hydrocarbon, if you attach a particular molecular formula at the end or in the middle, then they will act as a different compound, and these chemical formulae or these molecules are called the functional groups. You will understand better when I show you them. So the first one that comes into the list of functional groups, so we are doing functional groups. So the first one that comes into the list are halogens. Halogens means all the, if you look into the periodic table, the elements of the groups 17, that is fluorine, chlorine, bromine, iodine, these are all halogen elements. So halogen means if they contain things like chlorine, bromine, iodine, fluorine, etc. Okay, so how do you show that in a chemical compound, I mean in a carbon compound? So suppose we take one carbon compound, ethane. Okay, if we take ethane as an example, which the formula of ethane is CH3, right? That's the formula of ethane, and if I draw the structure of ethane, it will be better for you to understand. This is the structure of ethane. General structure, chain structure of ethane. Now what I want to do here is I am going to attach the functional group in any of the positions. So we are not going to replace carbon, we are going to replace any of the hydrogen atoms. Okay, any of the hydrogen atoms. So let us suppose remove the last hydrogen atom. So suppose I want to add any one of these, suppose chlorine. Okay, so this is ethane, right? So I am replacing this hydrogen with this chlorine. So what does the compound become? Right? So here we have attached a chloride. Since it is bonded means it has actually acquired one electron. So this is actually it will be in the form of an ion when it gets attached. Okay, so let's consider this as chloride. Okay, so when this chloride gets attached to this ethane structure, the formula is now changed. The formula is C2H5Cl. Right? So this is the functional group part. We have attached a halogen atom to one end of the carbon compound by replacing one hydrogen, and as a result this compound now becomes chloroethane. Okay, now this is called chloroethane. The name has changed from ethane to chloroethane because we have attached a functional group chloride to this carbon compound, and the family of these elements is called the halogens. The next one that comes are the alcohols. Alcohol functional group is a simple hydroxide functional group. So if you add an OH to any of these, then it becomes an alcohol. This is an alkane. We have converted alkane into a chloroalkane. Now we are going to convert an alkane into an alcohol. So how do we do that? Again, let us replace this hydrogen and we can get C, H, 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 H and OH. So here I have attached the functional group. On attaching the functional group OH, this is converted into an alcohol, and hence the name of this compound is now changed from ethane to ethanol. Okay, so here it was chloroethane, now it has become ethanol because it is converted into an alcohol. So what actually happens when you change these functional groups? They have change in their properties, in their chemical properties and in their physical properties as well. So as a result, you can have different reactions for different compounds falling under different functional groups. Like we will not have these in class 10 as of now, but most of these you will learn in higher secondary classes, means 10+2, where you will see that these compounds, this ethanol is a type of alcohol. You can have propanol, methanol, butanol. So alcohol is a group, a huge functional group under which there are many compounds. So how do alcohols react with other compounds? These are a separate section. Then you will have how do halogen hydrocarbons react with other compounds. Then we have the remaining three functional groups, and you will learn how those functional groups or carbon compounds containing those functional groups react with other compounds. So these are huge sets. We are just getting a glimpse of this in class 10. So just try to understand that when we replace or if we add one of these groups into a carbon compound, they get converted into a different type of compound. Like if you add OH, they become alcohol. Then we have aldehyde. And the formula for aldehyde is CHO. Okay, the structure of it is different. This is CHO and its structure is like C double bond OH, because oxygen needs to be bonded with a double bond, because oxygen's valency is 2, so it needs to share 2 pairs of electrons. When oxygen shares 2 pairs of electrons with carbon, it forms a double bond. So this is actually the structure of aldehyde. So again, let us replace this hydrogen. What do we get? Let me write the structure. Okay, let's not write this. Let me write the structure. So I have replaced the hydrogen that was present here with C double bond OH. So this is our functional group. So this is now changed into an aldehyde because I have attached a C double bond OH group to this compound. What does the name become? So here now we have 3 carbon compounds, right? 3 carbon atoms. 1, 2, 3. So the name will change to, for 3 carbon, it is called propan. Okay. And since it is aldehyde, the name is propanol. So name has changed now, it is propanol. So how do you understand what should be the name? For halogen atoms, whatever you attach, suppose you want to attach bromine, it will become bromoethane, iodine, iodoethane, fluorine, fluoroethane. So that's how we name them. In case of alcohol, just count the number of carbon atoms. You write ethan, methan, propan, whatever it is, ethan, methan, propan or whatever, butan, hexan, pentan and like this, and you add a suffix to it called ol. And however, where does the ol come from? Here, alcohol, so it will become ethanol. Okay, here it is called aldehyde, that's why it becomes propanol. This L part comes at the end of propan. Okay, so that's how we name them. For alcohol, you will add propanol, ethanol, methanol. So all will come at the end. For aldehyde, it becomes ethanol, propanol, methanol, like this. Then we have our next one, which is called the ketone. The ketone functional group, and it is like C double bond O. Just C double bond O, CO. So now look into this. Here in all this, we had one arm empty. In this compound, we have 2 arms of carbon empty. So we can't attach it to an end, because if we attach to one of the ends, you will have one arm empty towards the right hand side. Hope you can visualize. If I attach this carbon to this end, what will it become? It will become like C double bond O with an empty arm. So we can't do this. So what we will do, we will attach it at the middle. We will insert the C double bond O at the middle of these 2. So what do we get? We have one carbon and we have our hydrogen atoms. Then we have this, just like we had, and in the middle we have inserted the C double bond O. Okay, so this is our functional group. Okay, clear? You take the carbon from the ketone group, C double bond O, insert it anywhere in the middle. Don't insert at the end, then you can't form. So ketone groups are always found in the middle of the carbon compound, somewhere in the middle, not exactly in the midpoint, but somewhere in the middle, not at the ends. So this now contains 3 carbons. So again it is propan. Since it is ketone, you take the one from here and you add it to this. It becomes propanone. Okay, that's how you do the nomenclature, the naming of the compounds. So hope you understood these 4. Let's move on to the 5th one, and the 5th one is called the carboxylic acid. Let me erase this part, halogen. The next one is called the carboxylic acid. And carboxylic acids have a structure C double bond O OH, which you can simply write as C double OH. Okay, this is the longest one. These were very small. This was still a bit big. This is the longest one. C double bond O and with an OH. So it is, in short, we can write C double OH. So here again one arm is empty. The remaining arms are fulfilled. So again we can add it at the end. So what do we get? Let's add here. So we have C H H H C H H and then C double bond O OH. This is our functional group of carboxylic acid. So what does the compound's name become? Here we have 3 carbons, so again propan, and for this we have oic acid. This ic will come. So propan oic acid. Okay, this O comes as extra, but this IC comes from here and acid you add from here. Okay, so these acids are called oic, means OIC for nomenclature. This will be oic acids like propanoic acid, ethanoic acid, pentanoic acid, hexanoic acid. Okay, so that's how we do the nomenclature. So hope you have seen all the functional groups and you can attach it to any part of the carbon compound. It's not that you have to attach it only to this end. You can attach it to any of the hydrogen. Replace any of the hydrogens with this and you can get a functional group attached to the carbon compound. Hence you convert the alkane or alkene, whatever you take, into a different compound containing a different or certain functional group. So that's how all the functional groups are attached to carbon compounds. So hope you have understood this. Now we will move on to the important part, the really important part of the chapter. Means actually based on the 2021 revised syllabus, you will only have the 4 reactions of carbon compounds. The remaining part is not there. So let's move on to those 4 reactions of carbon compounds. So what are the reactions that we have in this part? The first one is the combustion reaction. Then we have an oxidation reaction. Then we have an addition reaction, and finally we have a substitution reaction. So first one is the combustion reaction. Very simple reactions these are. So I hope it will be easier for you to understand and remember as well. So combustion means you need oxygen, because combustion can't take place without oxygen. So carbon compounds reacting with oxygen will give us carbon dioxide for sure. So if it is only carbon, suppose no hydrogen is present, so if it is only carbon, it reacts with oxygen and it will give you carbon dioxide. Right? Very simple equation. Now since it is a combustion reaction, obviously it will produce some heat as well as light, because it will burn, so it will produce light and heat. Okay, so that's the reaction if it is only for carbon. Now if it is a hydrocarbon, suppose I have methane CH4 and I go for combustion reaction. So CH4 reacts with oxygen, and what is the outcome? Obviously carbon dioxide you will get, and the hydrogen will react with oxygen to give H2O along with heat and light. Okay, so that's how the reaction pans out. Now you can put any compound, any carbon compound. Suppose you want to put ethanol like C2H5OH plus oxygen, it will again give you the same product, carbon dioxide, water, heat and light. Okay, so any carbon, hydrocarbon containing any functional group, if they react with oxygen, they will give you carbon dioxide, water, heat and light. So very easy to remember because the products remain the same. Just keep in mind that if it does not contain hydrogen, then water will not be produced, because you don't have hydrogen. How can you form water with that? So if you have only carbon and oxygen, you will form carbon dioxide along with heat and light. If you have carbon, a hydrocarbon means a carbon along with a hydrogen, 1 or 2, how many, whatever the number of hydrogen may be. If you have carbon and hydrogen together in a compound and they are reacting with oxygen, then the carbon will react with oxygen to give carbon dioxide, hydrogen will react with oxygen to give water along with heat and light, because it is combustion, so you will obviously have light and heat in this reaction. Hope you understood this part. Let's move on to the second reaction, which is the oxidation reaction. So oxidation you have studied earlier as well in our previous chapter. The oxidation reaction means addition of oxygen or removal of carbon dioxide. Addition of oxygen or removal of hydrogen. I got caught up in this. So either you have to add oxygen to something, then you can oxidize that thing, or you remove the hydrogen from there, then also you can oxidize that thing. So what we are going to do here is we are going to do oxidation reaction, but in a different way. Earlier what we did, we added some compound plus oxygen gives oxidation reaction, right? Now we will use something different called oxidizing agents. So what are oxidizing agents? Oxidizing agents are those compounds that have the ability to oxidize other substances. Okay, suppose I am an oxidizing agent, then I will be having the ability to oxidize someone else. Means I will have some oxygen in me that I can donate to other compounds so that that compound can get oxidized. So if suppose a compound A has an oxidizing property, it is an oxidizing agent, then what it will do, it will give the oxygen to B, and B will get the oxygen and it will become oxidized. Okay, so that is the function of an oxidizing agent. Now in this reaction, the reaction that is given in the book and that we are going to see now, we are going to use two types of oxidizing agents, either of the two. The first one is called the alkaline KMnO4, that is alkaline potassium permanganate, or alkaline K2Cr2O7, that is acidic potassium dichromate. So either it is, the agents are alkaline KMnO4, potassium permanganate, or we can use acidic K2Cr2O7. Okay, now you must remember that this potassium permanganate will only act as an oxidizing agent if it is present in an alkaline solution. So if it is basic in nature, then only it can act as an oxidizing agent. K2Cr2O7, if it is present in acidic medium, then it will be able to act as oxidizing agent. Don't switch these two, okay. KMnO4 in acidic condition will not act as oxidizing agent. K2Cr2O7 in alkaline condition will not act as oxidizing agents. KMnO4 will only act as oxidizing agent if it is present in alkaline condition. So you must write alkaline KMnO4 that will act as an oxidizing agent, and acidic K2Cr2O7 that will act as an oxidizing agent. So you must remember these two, okay. So these are our oxidizing agents. See, you can see here they contain oxygen. So they can donate the oxygen and oxidize a given compound. So what do we do here? So in an oxidizing reaction, we will take an alcohol, react it with these oxidizing agents and see what happens. So let's take an alcohol. What is given in the book, the reaction that is given in the book is, it is ethanol, CH3CH2OH. This in the presence of either alkaline KMnO4 or acidic K2Cr2O7, it will be oxidized. Now which part will be oxidized? This H2 here will be removed with the oxygen. So what we form here is CH3COOH. See, this hydrogen here has been removed with a, or replaced with a oxygen. So since hydrogen has been removed and oxygen has been added, this reaction is oxidizing reaction, oxidation reaction. So if I draw the structure, it will look something like this. This is the structure of the alcohol, ethanol, and what we will do here, we will remove these two hydrogen. So it will ultimately, what we form here is this C double bond O OH. So two hydrogen has been removed to accommodate one oxygen. And what is the functional group here? It is carboxylic acid functional group. So what we have done here, we have taken ethanol and converted it to ethanoic acid. That means we can convert an alcohol into a carboxylic acid by using oxidation reaction. So you may get questions like this where you are asked, give an example of a reaction where you can convert an alcohol into a carboxylic acid. It is oxidation reaction, and that's how you do it. Okay, remove hydrogen, add oxygen in the presence of oxidizing agents to have an oxidation reaction. Let us move on to our next type, that is addition reaction. Now what happens in addition reaction is, as we have discussed in our previous video, that if you want to add something to a compound, you need an unsaturated carbon compound. Because if the compound is saturated, then you can't add anything because all the bonds are single bond. Where will you add something? In order to add, you have to break the bond. You have to break the compound, which does not make sense. So if you want to add something to a compound, you need a double bonded structure or a triple bonded structure, means an unsaturated carbon compound. In that case, if it is a double bonded structure, you remove one bond. On removing one bond, you open up two other arms. Let's see what I am talking about here. In addition reaction, what happens? What do we have here? Suppose I take a double bonded carbon compound. Suppose I take ethane. ethene. This is ethene. Okay. Now in ethene, I want to add, suppose I want to add hydrogen to it. Okay. Just one fact here that I need to mention, that in addition reactions we need a catalyst. Now what is a catalyst? A catalyst is a compound that will help to speed up the reaction. It will increase the speed of the reaction. It will not take part in the reaction. It will just increase the speed. So the catalyst that we use here is a nickel catalyst. Nickel is an element. So we use nickel as a catalyst. So what happens here is, I want to add hydrogen. So what do I do here? I will remove one of the bonds here from this double bonded structure. So what I mean by this is, I will make a single bond. So what happens with this making of a single bond is, now we have two extra arms for both the carbons, and we have two hydrogen here, add one here and one here, hence we have formed a new compound. Now this is a saturated carbon compound, saturated. All the bonds are single bonds between carbon atoms. If I want to add something to this, will I be able to add? No, I can't add, because all the arms are fulfilled, and if I want to add something, I have to break this bond, which does not make sense. It will break the compound itself. So you need to have a double bonded structure or a triple bonded structure in order to add something to those compounds without breaking the compound. We will break a bond but will not break the compound. So suppose I have a triple bonded structure. What happens then? Suppose I have this. Then if I want to add hydrogen and I have nickel catalyst, then I can convert this to this as well. Remove one of the bonds, open up two more arms and add hydrogen. So that's how you can convert an alkyne into an alkene into an alkane. This is what? This is ethane. Right? So this is alkane, this is an alkene, and this one is ethyne. That means it is an alkyne. So you can convert an unsaturated carbon compound into a saturated carbon compound with the help of addition reaction, and the catalyst that we use is nickel catalyst. Make sure you mention the catalyst, because it is an important part of the reaction. Otherwise the reaction that will take place will be too slow to take place. Okay, so we need the catalyst to speed up the reaction. Now let us move on to our last reaction, that is the substitution reaction. So what do we have in substitution reaction? Substitution, from the name itself you can understand that something has been substituted, means it has been replaced by something. So what reaction do we have? Suppose I have methane, okay, and I want to substitute some element here. So let me take chlorine. This is the reaction from the book that I am taking, okay. So methane will react with chlorine. Then what will happen? See, let me do the structure. Okay. So here what happens? This chlorine will come and it will replace the hydrogen. So hydrogen will be removed. So chlorine will take the position of hydrogen. So the hydrogen will be alone here. Now one of the chlorine has come here. What happens to this chlorine? This chlorine is also empty. Now this will react with this hydrogen. So the main thing is, this chlorine is replacing this hydrogen. They are switching their places. Okay. So what happens? What is the outcome that we have? Since this hydrogen is removed by the chlorine, so what we have here is a chlorine here in place of the hydrogen, and the hydrogen will react with the remaining chlorine to form an HCl. So what was this? Was a simple alkane. We have added a functional group here, halogen functional group. Remember from the functional groups, this is the halogen functional group. So the halogen functional groups gives the name of the compound Chloro Methane. Originally it was only methane. We have added a halogen to it, making it chloromethane. So what do we have here? This can be written as CH3Cl plus HCl. That is how we do a substitution reaction. Why chlorine has replaced hydrogen? Because the reactivity of chlorine with carbon is much more than that of hydrogen. That's why chlorine has the ability to replace hydrogen and form a chloromethane. This is just because of reactivity of chlorine with carbon. Chlorine has more affinity towards carbon. Affinity means attraction. So chlorine has more affinity towards carbon, and hence it will form a bond with carbon by replacing hydrogen. So we replace one of the hydrogen with a chlorine. That means we substitute a hydrogen with a chlorine, and hence the reaction is called substitution reaction. Hope you understood this reaction, and hope you understood all the reactions that we have done today. That is all about today's video. If you have any confusion, make sure you ask me in the comment section. I will be there to help you out. And this is the end of the chapter if you are considering 2021 syllabus for general science HSLC. So that is all you have up to, that is all you have in the syllabus. The remaining part is not there in 2021. You will have it from the next year again. So thank you everyone for watching, and until next time, cheers.